What's going on, everybody? We're live. This is another episode of what we were calling STL Sunday. I'm going to try and change the name to 3D Printing Sunday, just to try and convey more to what people, what this is, if they don't know what an STL is. I realized that STL was a term that not a lot of people knew. STL is normally the file extension type of parts that you 3D print. People don't get that. So 3D Printing Sunday. What we're going to do in this series is I'm going to walk you through the design process that I take while coming up with an idea and wanting to take it all the way through to completion. We're going to be using Fusion 360, which is a CAD program that you can download a free version of in some countries, not all countries, but in the US especially, as well as Canada, I believe, you can get a free copy. It's not the easiest thing in the world to navigate through their system, but you can get a free home use copy. I've linked to where you can get the software in the description below. Check that out. That will give you an idea what we are doing. Thanks everybody for checking in. See where everyone's coming in from. Let's see, we've got Portland already. Yeah, I'm early. I started 1 minute early, just on principle. A little early today. So again, let's check out where everyone's coming from. Guess it's time for a 3D printer. Yes, it is time for a 3D printer. You should be, if you don't have a 3D printer yet, get one. And then learn how to use the software that we're going to go through. We're going to break it down, give you the ideas, and it's not as hard. You just got to get in and start doing stuff. KC, oh, John's Tiny Trucks is in here. John printed by far the best version of the skee ball machine from last week, fully functional. John, I would love to pay for your digital supplies that you know, the digital message board and the ball bearings. Shoot me a message and I'll give you an Amazon gift card number. So let's see, Nova Scotia, Canada, Hollister, Savannah, Georgia, Roseville, California, just up the street, Argentina, still down at the Ozarks. Nice, love the Ozarks. Alberta, Canada. Let's see, I got a Clear Lake, Maryland, Michigan, South Bend, Indiana. Ooh, just jumped on me good. Let's see. Kentucky, Nova Scotia, Manitoba, Charleston, Bidwell. It's only a free year. Yeah, it's 1 year free. You can extend it, and then of course there's other ways. But either way, it's worth it, especially if you get used to using it. It's definitely something to buy. Holland, New York, Texas, Florida, everywhere. Getting a good group. I appreciate you guys for checking in. This isn't the most popular series I have, but it's one that I do enjoy, and it's something different for me. It's RC related, but it's a little bit of a break, but something I use for RC just all of the time. So anyway, this week I've got one simple project that I would like to do, just kind of like a funny thing, but then I'd like to pull some sort of fun suggestion out of the chat. I kind of like when we just come up with a random idea. The go-kart was an idea that someone had brought out of the chat, and I thought that was hilarious. But the first one I wanted to do was something for your scale garages again, and it's like an inside, or it's a joke a little bit. But you know how people always take pictures of their scale trucks on the washer or dryer? Well, that must mean that everybody's scale garage needs a scale washer or dryer. So I think we should draw that. That is my first object for tonight. So while we think about what else to draw, I've got a blank opening, whatever you're going to say, Fusion here. One thing I do want to do is I think we should, let's just go to Best Buy. Go to bestbuy.com and see what they have. Of course, they have pop-ups. No way. I need one for sure. Washer Wednesday. Yes, Video 22. Always posting the Washer Wednesday photos on Instagram with the Harley Designs hashtag, and I think that it's funny every time. So, you know, the Amana 3.5 cubic foot, I think that's a standard, right? Everybody needs the Amana 3.5 cubic foot. But what I'm looking for right here, see some dimensions. This is why when you have something so we've got exactly the dimensions we need. Boom. So I'm gonna just, we're gonna take this thing and I'm gonna draw kind of a side profile first. So we're gonna need the 27 and the 42. Jake was asking, where would be a good place to buy a TiVo Tornado? It looks like the TiVo website is out of stock. Jake, right now with how everything is, seems like TiVo has kind of, I think that they got bought out by a company called Homer. And honestly, right now, I would tell you to go buy like a Creality. Go buy one of the Enders. I've had great luck with my TiVos, but I don't know what's going on right now. So I have a hard time telling you that I think you should go buy one as well. So go pick up an Ender. Go to, Amazon or their website, wherever, and go from there. Okay, so this is the side profile we're drawing. We know that it's 42 inches tall, so we're gonna do 4.2 inches. So that's, and then 27 inches deep, so 2.7 inches. And I'm gonna try and keep an eye on the chat for good suggestions of what to do next, but because this thing's gonna go fast. I drew a simple profile just with the line tool. I used the D key for a hotkey for a dimension. 8 millimeters sounds great. How tall do we want this? 15, sure. I'm just slamming some dimensions together here. So we got that. Now we're going to extrude this. And it was 27.5 wide, so we need to go 2.75 inches. Boom. We're done. Looking at this thing, see we've got a little bit of a curve to the top, some rounded edges. We got to put some dials on it. I think we should make it open, right? Micro Center has the Ender 3 Pro for $199, John says. That is a freaking steal. Let's add my favorite things first, and that is going to be some radia. Actually, let's add just like a, no, I want this to print as nice as possible. That looks fine. Let's round these corners a little bit. Just bring that all the way around. Oops. Let's go with 2 millimeter radius. Yeah. Let's do the same on this. Something like that. I think we should try for a slight depression on the top. So let's do a sketch, select that top plane. I'm gonna go normal to that surface. I'm gonna hit the P key for project, select that. That gives me the line work around the outside so that we can work with that. Then I'm gonna grab that and just bring it in. 3 millimeters sounds good. We're gonna go -1 millimeter down. So that just kind of gave us a little bit of that. I just want this to kind of, actually, before we do that, I'm gonna round all these, all these inside corners because it'll allow us to kind of bathtub this top a lot easier. I'm gonna get up and read a bunch of your guys' suggestions here before too long. Oops. So I rounded all those edges that way, all those inside corners, that way when I click this, it chains around it much easier. So you see, I just kind of wanted that like depressed inside. And then we're gonna put a light one around the outside, like 1. 1 might even be a little heavy. Let's go 0.75. There we go. So another thing is that kind of looks like, you know, these things always have like that top lip around it. I think we should add that. So let's offset a plane. Let's offset the bottom plane. To about there. I'm just eyeballing it. So now we're going to make a sketch on that plane, and then I'm just going to go to the bottom, hit P for project, and do that. That'll give me all of that line work up around that section. Then I'm just going to offset that inwards negative 0.4 millimeters. So it's just a tiny, it went the opposite way. I thought negative would give me the right. So we're just gonna go 0.4. And then we're just gonna do a 0.25, or not, let's do a 0.4 millimeter cut as well. Yes, Suki is being loud out there, but that also means that she's out and about, right? So let's do 0.2 millimeter fillet on the inside. That'll give it on both top and bottom. That kind of gives us that half round there. Okay. So that little line is just a tiny detail line for a tiny bit of style. Okay, now let's do some drawing on this top. I think we need to do, let's do L for line, X for construction. Now, add some points. Actually, take those points off. We're going to do the symmetry constraint. That does that. That means that constrains them so that now we can equally keep everything equally spaced off there. Let's do 21 is fine. We'll do 5 millimeters off the side. Right now, 3 millimeters down will be fine. I'm going to do one more. We're going to offset that. Let's do -3. That'll be fine. So those I'm creating so that we can create creating a couple of things. The lid, or where the lid will go. I also went down 3 millimeters on that first cut. I feel like that was too much. Let's go 2. So there's that. Now I also want to change that second cut to 2. Now, let's see if we can shell this whole thing. Inside thickness of I'll do 2.4. Oh wait, let's see if we can select the whole body. It doesn't want to shell. That's okay. We'll do it the other way. So we're going to grab that geometry. I'm going to try and thin this thing out so it's way faster for you guys to print. And I guess we could even, you know, if we wanted, we could get crazy and put the we could put a drum in it if we wanted, right? So I cut out the whole inside, which is just for simplicity. Yes, hit the like button if you guys haven't had any luck with the shell feature on the designs, John says. The shell feature in Fusion can sometimes be a little funny. I have a lot better luck with it in SolidWorks, but anyway. So the one thing is that I think we could, if we leave this like completely open, it's going to print with a lot of support material. And I don't know, I mean, you might be able to get away without it. I think that a lot of your guys' printers, like mine, would probably print that bridge without much problem. And since it's underneath, I don't really think that you would have much of an issue. I think we're gonna leave it that way. Or should we put, someone decide, should we put a drum on the inside or not? Make it actually like a I was just actually thinking exactly like John just said. Make the top separate. We'll slice off this top right here. Then you can just print it however you want, and it won't be any issue. Drum. Okay. Looks like we're gonna do that. So there is a split body feature. This tool right here, body to split. We're gonna select it. Splitting tools. That. I'm not sure. Let's see. We're going to see if that'll allow us to. Boom. It worked. Now, I would like to have it split at that line, but it doesn't. It's not as clean because it still has this half of this open section. What do I want to do? Do I want to leave it like that or not? I feel like no. Yeah, we're going to undo that. Let's see. Dang it. I guess we're just gonna. There's a couple of easy ways to do this, and I think I'm just gonna. We're gonna do it about like that. Although if we just go to the midpoint, we're gonna go to there. That's fine. So now we're going to create the second body back on that plane. We're gonna create our geometry based on that surface. And lastly, I'm going to offset that outside surface -2.4. So that puts us right where we need to be. So I think it was it 88? One thing I forgot to do is I need to make sure that this is not select at join, but at new body. That separates. Now we have two separate pieces still, but the top now has everything kind of inset. So one thing I want to do though is I want to go I want to create, let's see, 0.25 inward. I want to do that just so that all of our I'm giving ourselves a little, right now, like the cut I made would have been a perfect cut. And now it'll inset it a little bit, so it'll have a little bit of wiggle room to get set down in there. So now everything will just fit better. You won't have to be as concerned. I want to, when I cut, I went -88.2. Okay, just making sure. When I made that new bottom part, I did 88, so we're still pretty close. All right, so now if we hide the top part, let's put a bottom back on this. -2.5, because why not? So that put a bottom in it. Just use black. See, everybody better print this. They better buy themselves white PLA. You gotta do proper Washer Wednesday photos. So now, what does the inside of a washing machine look like? Inside of washing. I don't do laundry. Okay, when you open the lid. When you open a lid, it's circular, not a square open. See, this is what happens when you don't do laundry. Okay, so we needed a round. All right, we're gonna fix that on this top one, but yeah, I don't do laundry. Okay, so let's add ourselves a bearing pocket on the bottom first, right? Because you guys are going to want to put a bearing in there. A fast eddy bearing, you should, right? So we're going to do that. C for circle on our keyboard. C for circle, X for to turn off construction. So we're going to make two circles. First one, we're going to do 11.2 millimeters. That'll allow a 5x11 bearing to sit in there comfortably. And then we'll do a 4 millimeter outside. Let's see. Make it functional, brushless power. God. So now we're going to extrude that up 3.9 millimeters. And one other thing we're going to do is we're going to make a recess in the center so that the inner bearing race does not touch. So we're going to make that a 1 mil, and then that is going to go -1. So now everything will sit in there just fine. and a pulley so we can rubber band it to a motor. I'll make that possible, and then it'll be up to you all to make it happen. Or maybe we get fancy and we make it functional by hand so that I have an idea. Okay, so now we're going to start on that surface. We're actually going to print the lower shaft, which is going to be 4.9 millimeter. We're going to print it into the drum. So it's going to go up 5 millimeters exactly. No, we want power. Maybe we can make it work either way. We'll see. Make sure you level out the washer so it doesn't dance. All right, now let's make that a 52 millimeter. I think a 52 millimeter drum sounds fantastic. Oh, did I make sure to... Okay, still all separate. We're good. Question, when in Fusion 360 I've designed stuff for bearings to go in, but when I print piece of bearing never fits, I always off by a little. What am I doing wrong? The thing, like I just did here, I did 4.9 millimeters or 11.1. You got, printers are just not super exact. They're fancy hot glue guns. So things are just never going to be exactly right. So you got to just give yourself a little buffer when you're designing. Don't print it. If you have an 11 millimeter bearing, don't make it 11 millimeters. Make it 11.1 so that you have a little bit of wiggle room. And things will kind of, you can go through and tune your printer to be just dead nuts, maybe. But you might get a different roll of filament and it might be different. So just give yourself a little wiggle room when you're designing so that you don't have to worry so much, because it's one of those, to my a dancing washer. Yes. Let's turn this back on. Turn both bodies back on. That's probably all right. Think? Yeah? No? Yeah. Sure. We're going to call it all right. Now, that's a pretty tall feature to try and just have hanging around out there. Let's get fancy. Let's select this surface. Offset down 12 millimeter. Then let's draw on that surface. And what we're going to do is this. We are going to, I'm going to draw a circle first. That's 11. Let's draw a few of these. So we're going to hold control, select all three, then hit equal. I guess we're going to need 4. So we are going to, now let's, just like I said before, let's make this 11.2. We're going to give ourselves even a little bit more wiggle room. I'm drawing this square. We're going to change it to construction on the right side on the palette. We're going to make sure all of these touch there. You guys will probably see what I'm doing in just a second. But now I'm going to make those tangent to that drum. And now, actually, all of those can be construction also. Shouldn't the drum be offset to the front and motor pump sit towards... All right, you suppose you're right. Didn't I tell you guys I don't do laundry? Go back and edit that. Nope, it's further back than that. Let's see. Okay, it's this one here. So let's edit this one. Edit sketch. So this shouldn't be there is what we're saying. Make sure that it's horizontal still. But I see why, because you got all the controls and everything and whatnot. Okay, let's go 26. That's probably too close. 28. And if with the offset, I think that we're going to be able to get away with much fewer bearings. Yes, yes we are. Okay. So we are going to basically what we're going to do is bearing center this drum so that when you guys try and put brushless power to it, there's that. And then this one is just going to go, I don't know if it's going to fit. Not quite enough. We can, I think even in that case, it's probably still gonna, will probably still work. Let's assume so. Let's hope that our 3D printed washing machine works well enough, because it really, really matters. It's crucial that this washing machine functions properly. So let's do 4.9 on these circles. These are going to be our bearing pins, because these are the ones that we want supported on this. We're going to go up 5 millimeters. Create a sketch on the bottom for support. And then now what I'm going to do is I just need to actually first we're going to just create a small area for that bearing to ride on. So we need it to be 1 millimeter larger than that inner portion, and that is just so that the inner race of the bearing doesn't have to rub on anything. Let's see. Just gonna say 1 millimeter. Chibs is just joining in. Let's see if Chibs can guess what we are making. Michael Kubota just jumped right in and let him know we're making a 3D printed washing machine for everyone to make scale photos of. Now you can take scale photos on your washing machine. So let's do I don't like that. We're going to grab some profiles of these and that. And now we're just going to create some line work to give these things this is sloppy line work at the moment. And then I'll go through and we're going to add a bunch of tangent constraints. Right, now these ones in the corner, I'm just going to put horizontal or vertical constraints on. Then back here, we're just going to go dimension. 45 seems way too steep, but what are we worried about? Now, it didn't join those because I didn't have that body. There. So now, that gave us some bearing supports for that drum. So now you can drop 5x11 bearings on each of those. And you can have a well-supported washing machine. So it's still a little offset, but you know, I mean, yeah, that's not what it's a 3D printed washing machine. What do you want from me? We need to edit this sketch here. No, not that sketch. Need to roll back. Where was it at? There it goes. So we're going to delete that. This needs to be a circle opening, right? So I'm told. So I've learned all of a sudden. Let's see, where is my centered line? There we go. That almost looks proper. So it's not perfectly centered. It's close enough. Close enough. Do we have enough room? Yep. Just enough. That looks good. One thing I want to do is go in and add a small chamfer to the top of these, just so that you don't end up with some 3D printed material kind of holding you back. But okay. Now, the other thing I was thinking was, is there a gear tool in Fusion 360? Has anybody tried that? I'm sure that there is. I just don't, or circular pattern. I mean, we could pattern it ourselves, but I was really hoping that I could just. I've never tried to draw a gear in here. There is, John says. All right, that makes me feel better. Is it under polygon? No. I don't see it. 40. That's what we're trying to go for, is some sort of pitch design. Does anybody know quickly before I have to, because I can't go on YouTube while we're on here because I don't want to pull someone else's video in. I'm sure there's somebody who knows watching this after the fact and is just no. Well, we may have to do this. They show a spur gear in search. Let's see. Well, first let's save this. I hit F1. Is there a help menu in this? No. Gear. I'm trying in their search. We'll see if that. No, nothing. Okay. S for scripts, old file I'm looking at. Spin it so fast it explodes. That we could. It's a possibility. Dang it. We may just. All right. We're just going to. I'm going to wing something together, and we're just going to see if it works. Maybe maybe I can refine it after the fact, and we'll see. But whoops. Let's see. 1 millimeter tall tooth seems too fine. Let's do McMaster-Carr has the grab. Has them grabbed from the catalog. That's a possibility. That's not a bad. So if you go on McMasterCarr.com and see, so if we go gear, if we go down to pitch, say we go 48. And then tooth count. Let's see the size of that. Let's see what an 82. Let's see what size an 80 tooth is. A 1.7 inch OD. If we go back here and we inspect this, our diameter is 52, which is just over 2 inches. So that's going to be too small. So what size is the 96? 96 OD 2.04. Simple groove pulley. You know what? I think I like what Canyon Racer is saying. Just because size-wise, this is going to be a pain. Plus, just bringing in another thing. Let's delete that entirely. So if we're gonna exit this sketch. And now we're going to create a sketch. Of course my origin's not. Why didn't I put my origin in a reasonable spot? Down like the center. I wasn't thinking tonight. So let's just do it. We're gonna pull the bottom. Grab that, offset it. 2 millimeters is going to be fine. We're just going to make that go up 2 millimeters. We're going to construct an offset plane, maybe 3 millimeters. That should give you plenty of distance for whatever belt you can think of. Then so now you're just going to have to find a belt to put around that. Let's make sure that, where is our section? So we're using the section analysis. I just want to make sure that I've got enough clearance. Ooh, look at that. I was right at the, so let's adjust that just slightly. I made that 2, let's go 1.5. Gives us a 0.5 millimeter more clearance. So now we'll do an interference check between all of that. Hit compute, no interferences. So everything's good. All right, so we've got that. Now we're gonna change our visual style to shaded with hidden edges so we can see where our groove needs to be. We're gonna make a hole on the back. You'll see what my thought is here. I'm gonna make oops. Let's go 4 millimeters. Now I'm going to do a quick inspect. $15 is fine. None of these dimensions are really critical, so I'm just kind of throwing some things together for now. We'll adjust as needed, but I always like to have my dimensions be so we're going to cut that window. Then we are going to create a 9. Let's hide the top. We're going to adjust these as needed. I'm just starting something so I can kind of work from it. We're going to go up 6. Well, I might need to go up more than that, but yeah. Let's adjust that. Up like 12. I think we'll work with that for now. I can tell already that we're going to have to adjust that a little bit closer, but it's okay. We'll get there. So what I want to do while we're at it, make sure I offset that one. So, well, I think we need to offset that a little bit higher. I want that bearing to sit up there. So much for quick and simple. Gonna be awesome though. Yeah, exactly. That's how these always turn out. If you guys didn't make me put a drum in it, we'd be done already. So now let's look at, see, this is what I'm looking at here, is this circle, which right now is colliding with the drum. I need to make sure that it doesn't do that. So I'm just going to do that for a second, but we're going to go back to this first sketch. We're going to bring it much closer to the wall. I want this pulley to be able to, like that. So the idea is that you're going to put the, we're going to make this another pulley. You're going to put the O-ring around the drum and then around this pulley, and it's going to stick through the back slightly. So you're going to be able to just spin the drum of the stupid 3D printed washing machine for your shop. So this is going to be 11.1. This is, call it 19. So new body, making sure that it is bigger than the groove, which it should be. It is currently shown at 7 millimeters. Let's go to, well, if they're 4 millimeters thick, we need at least 8. We'll go 9 millimeters tall. Okay, and then we'll have to extend that center section up a hair more. And we'll double check a couple of things. I need to make sure that you're going to be able to get this in. Like right now we have some collisions, but John answered your gear tool question. Oh, I need to go back and find that. Okay, I need to go back and find that. I missed it for now, but I don't want to lose my train of thought here. So we need to, where was that offset plane we had before? So that offset plane, we need to sketch on again. And let's grab this outside. And then we need to offset it inwards, -2. I think should work. And I think we went 3 up, right? So now our two slots should end up or line up. Let's hide everything else. We need to do an offset surface 4 millimeters up, because we need to create a bearing surface in here. -1, and then we just need to extrude that 1 millimeter up. So I'm going to change my visual style back to the regular. Now we've got what we should have. We'll inspect. This should be 4 millimeters, which it is. And down here, this should also be a 4 millimeter pocket, which it is. So now we have our, I don't know what you want to call this thing. Should have just made it a friction spur with bearing. That would have been a possibility as well. And especially in 3D printing, it's rough enough, but you know, we didn't. All right, this. 2 millimeters here. What's that do? Actually works out okay. That. Added a little bit there. Can we? Added that. So I guess we could have we could pull that bottom surface up. It doesn't need to be. So we're going to call that top surface the same. We're going to move this one up. That'll work. Oh, John Deere said, click on tools at the top, then add-ons. There's a spur gear tool there. Tools, add-ins, script and add-ins. Ah, that's where spur gear right there. Okay, I'll play with that later. Thank you for that though, John, I appreciate it. I knew that there had to be something like that in here. So now, the only thing is that I'm concerned I don't have a large enough opening for that to fit down over before it so because this kind of needs to be able to come through a little bit, I'd probably put the lower bearing on first, feed that through, then put it all together. But I think that will give us sufficient room. We need to put like the thing on the inside, right? Your easy first designs never really end up easy. I know. Why do I make these decisions every time? Granted, we're only an hour in on this one. Normally, those simple first ones end up like 2.5 hours. I need to stop thinking that I'm going to have all of this extra time. Whoa. Or that we're not going to go overboard with whatever else it is. Okay, wait. I need to go back to what the inside of a washing machine looks like. So it's got some of those supports and things and some fins. Ooh, simple fins. I like the simple fins. I don't want to do a corkscrew today. I know we can, but I don't want to. All right, fins it is. Put the thing on the inside. That's what she said. Ba-dum-dum-ch. Okay, also looks like we need to make this part have some sort of recess. And then we're going to chamfer this inside. Not quite all the way, something like that. Sure. Sure, why not? They're agitators, not fins. Jeez. Call me the Maytag man. Looks like these things usually have a little bit more shaping to the bottom. Back to a chamfer. We're going to change this from equal distant to 2 distances. It's got a little style to it then. Now we need a offset plane to the center of that. And what we're going to do let's hide the basin, turn this so that we can see the hidden lines. It's always the suck part about. Oh, Derek gave me $9.99. Thanks for keeping my printer busy. Thank you, Derek. I always appreciate those on STL Sunday or 3D Printing Sunday. Now that we're changing the name so we can, so people understand what we're looking at. There we go. Let's change it to wireframe for the moment. And just make some hasty decisions here. We're going to constrain a few of these things to vertical. Let's see. Okay. So, finish that sketch. Oops. Now we're going to do a new body, symmetric, total distance of 1.5 millimeters, again, as a new body. Now, with that, we'll change the visual style back. And we're going to do a pattern. Where is the circular pattern? Why have I all of a sudden gone brain dead on where circular patterning or linear patterning, circular pattern. Thank you. Gee. Objects, well, we need to do bodies, not axis, which is going to be that. 3 instances. Boom. And now we can join all of these. So, now we've got the agitators, not fins. Okay, what else do we need to put some gauges. We need to put some dials on it, right? What are you making? We have made a 3D printed functioning washing machine. I need to make a lid, and we need to make the lid and the dials. If there's this much put into a simple washer, the stuff from Vanquish should be months of design. God, yeah. Same reasoning sometimes though. Like, oh no, this things get so simple, right? They should just be done. And oh my God. How many dials are normally on a washing machine? Should I ask Nicole? All right, go back to this. What did our Amana have? 1 large, 2 small. That is, seems appropriate. So let's make sure that these 2 are equal. We'll call those 5 millimeters, sure. Spacing of 8. Total size on this one, 11. Done. 2 millimeters out. Some fun little radius on there. I'm literally doing laundry while watching. Oh, I know what else we need. Aerial, we need to go to impact. Come on, text. Text is HD, impact, there we go. Now you're just going to just goading your wife. Yes, I am. So this is the cleanest thing you've done. Oh my God. Hilarious. Let's put a small chamfer around the opening on this. Oh, let's go back to equal distance, 0.5. Put your, is that a heavy duty washer? Okay, so we need to put a lid on it, but we need to make sure the lid can function. Let's offset it in by negative 0.5. Two millimeters up, new body. Go back, make sure that we put a chamfer on this of 0.5 as well. Save it while we're at it. Needs a cutout in the front of the lid to make it easier to open. Good call. Let's see. So we're going to make that midpoint. It can't be too big though, right? Whoa, what did I just type? Okay. Now let's just make sure that we have that. I feel like I could add like the like a, you know, something like a little hook in the back to make sure that the lid stays in place properly. But we are looking pretty close to the drum. That's going to be a little difficult. I feel like you guys are going to be able to handle it without that part. We drew a freaking washing machine. Can we all agree that I think we've spent more than enough time on the washing machine? Wow. You guys have been awesome though on the chat. I'm going to catch up a little bit. And then another idea that I had was that I would like to do like a multi-week project, something that we can kind of keep working on time over time. Maybe we do a project that takes way too long like this one, and then we start in and work a little bit on the next one. The idea that I had for that is I would kind of like to do like a trailer, you know, an adventure trailer or teardrop style trailer where we can have weeks of simple things that we could put inside or whatever. And it doesn't have to be, you know, it could be a ton of different options, but something along those lines, I feel like we could do. So a trailer is the first thing that came to mind. If you guys have other ideas, I would love to hear those. So throw those in there. I'm going to go kind of scroll back through the chat because you guys were freaking killing it in the chat tonight. And that's awesome. So I'm going to scroll back up, read some of your guys' comments. I appreciate it. A lot of discussions of what brushless motor we should put on this washing machine. The Holmes Outrunner, that, you know what, that would have been a good one. We could have done a friction drive with that. To me, a dancing washer was one of the best comments. Ryan Davis had that. There was some discussion about tolerance checking from Thingiverse. Motor and pump are below the drums on a top. Now we're getting into some technicalities for washing machines. We have talking about standard. Oh, you guys are great. Calling this a photo booth. Oh, that's the perfect. It's a scale photo booth. That is what we made. Oh, there's so many things. Oh, wow. I'm almost gonna have to go watch back and just look at your guys' comments. I appreciate it. Did you scratch the SCX24 3D print series? No, I still want to do some of that, and I've been working on it a little bit myself. I have some things that I want to do in combination with it, so I'm looking forward to that. A little bit of that coming, but there's some other things I'm trying to get done, so that I can start on that. Yeah, if a washer has 6 bearings, how many will a trailer have? Does this have 6 bearings? Let's see. Oh, I didn't really make a way for this top to connect to it, but I don't know. Maybe So, this has 1, 2, 3, 4 on the. It does have 6 bearings. Wow, you are correct. That is, hey, John Darian, $5. Trailers are cool. I won trailer competition at K&K last year. Oh, that's kind of fun. I think it would be fun. I think a trailer one is just a fun option. So, I think this thing will seat in there well enough that we don't really need too much. I don't know why I keep wanting to add things to our scale washing machine, but that was probably the best one. So I think for the rest of this one, I'm just going to create, let's go back and I'm going to save this first. Just now that we know we're done. If we do a trailer, which I'm thinking at this time, what about a golf cart drawing one night? That wouldn't be too bad. I think we could do a golf cart. Although, golf carts, that could get pretty good size. I don't know. That's a possibility. It's an interesting thought. Fast Eddie gonna have a part number for an HD washing machine? I bet I could swing that. 6-pack of 5x11s? Yes. If we do a travel trailer, let's just do a little bit of research tonight and just kind of see what let's see. I kind of like the teardrop trailers. Is there an overland version of teardrop trailer? Yeah, kind of like these style. Terra drop. That's even better. Riding lawnmower would be cool. I kind of like that idea. How about a wave runner? The wave runner someone had suggested before, and I really liked that one. I feel like I need to experiment with that idea. I like this little trailer here. And I feel like if we do a trailer, what I would do is that I would create the files so that you could basically 3D print all of it. Or I would also like to create the files so that you could 3D print the framework, but then actually styrene the actual, skin it with styrene on the outside, so that you could have a more smooth finish without doing 3D printing. Maybe it leaves you guys some other options of things that you could do as well. I think that a trailer like this, we could really kind of go crazy on, and you guys could you guys could kill it with some details. The one thing that's a little bit, difficult is just making sure that you have a strong enough connection or whatnot. But if we do it, you could always we could also make some templates where you could possibly cut out the base out of a different, like out of wood, if you wanted something that was more sturdy than just 3D printing. But I kind of like this little teardrop trailer, right? If we have that size overall, the dewdrop, teardrop alpha. Let's just look at let's just look at sizing for this thing. Does it say? Info and specs. Perfect. Main body, 5 foot wide, 4 foot tall, 8 foot long. Overall dimensions, 146 inches. See, all these things, brooder trailers. Ooh, what's Tony saying with brooder trailers? Oh, look at these things. Is this what Brooder X? Oh, these things are ridiculous. Look at the suspension on these. Oh my. I feel like we could almost make that happen. These things are just huge. We're gonna have to make a smaller version of these though. I like this style though. I think we can kind of go with this style. Do an Airstream. Let's see. It's got air ride on the brooder. Oh my God. Yes. So if you guys, if we think that if we go with a trailer, like if we at the regular size of the other one, if it's 5 foot wide, what's 5 foot 60 inches? So 6 inches on the body, and the overall length on the body of that one was 8 foot. So that's what is that? 90. What is 8? 8 times 12, is it? Yeah. So 96 inches. So 9.6 inches. So, okay, here's the biggest problem. We're going to have to look at a couple of things. If we do this, like an Ender 3's got a 220 millimeter bed. So we're going to have to figure out a way to break it up so that you guys could easily print it. And I'd want to take that into consideration while we were designing. So that would be just the cabin area of a trailer. And the overall dimensions of that thing were 146 inches long. So 14.6. If we take that, I'm just creating some random line work. Say we go from front to back, that's 14.6 inches. I feel like we could make something work in here. I think this is maybe along the lines of what we're going to start on next week. Is we're going to start on very simple. We're gonna come up with our first project, and then I think my hope is that we start on a trailer project and have some fun with that, because the trailer would be it would give us tons of items, like when you start looking at all the things you could put on the roof or all of that, it would make things, it would give us a ton of different ideas that we could still go with. It'd be the same size as a truck. I mean, kind of, yeah, but when you look at the same length anyway as a truck, which, or not quite. Trucks are usually a little bit longer, but like when you look at these things in use, they, overall lengthwise, I mean, it pickups a little bit longer, but they're not that much shorter. It's just, you don't have that as much mass when you look at everything. But what about those Christmas trailer. Oh yeah, I mean, there's lots of trailers. Trailers are, you know, people do a lot of them. I think just a 3D printed trailer that we have a number of options based around would all be fun. So that's the reason I bring that up. You know, we'll design an axle or find, you know, we'll just try and make it go through a number of things. Can you release files as you go? That way we're not, yeah, absolutely. Like every week we'll just say, here's the file for this week, get it out there. Here's the file for next week. Like, and it'll just be, we'll just go every week. Not a, you know, you guys can take it and go from there, and we'll have all kinds of things that we could do. So, yeah, it just, you know, Josh, you can do metal work for a frame and make panels to fill the model. Yeah, well, that's the thing, is if we do all the CAD work, we can easily create PDF templates. And if you guys wanted to make portions of it out of metal or wood or whatever it is, go for it. You know, like you can have different styles, but the CAD work will allow us to either 3D print it if you want, or make it however you want. Now, I will pay someone to print this for me when it's done. Either, you know, I'm sure that you could find somebody in one of these streams that would help you out. But I think this is a project that I feel like we should work on. If you guys agree, I think that will make us all happy. And I'm going to try and make sure that we break it up in ways that are going to be easily printable on most printers, even, you know, a standard Ender 3 220 millimeter bed. I just want to make sure that we don't design things outside of the capabilities of most machines. That's my hope. But tonight, I don't think we're going to, we're not going to dive into this thing too much yet, but I think this is around the general size of what we're going to go with. And I think I'll be happy with that. But most importantly, we made a washing machine. Scale wash. Now you guys are gonna have to find micro machines for your scale shop, placed nicely on top of your scale washing machine. I'm on board. Anyway, everyone should message Fast Eddie, tell them they need 6 5x11 bearings for their scale washing machine. You could use SCX24 wheels and tires for the trailer. I feel like those might be a little small. I feel like I'd want to make it around like a small 1.9, you know, like even that Class 0 Proline tire, 3.85. I think that would be like it wouldn't look too off next to, because, you know, that way you're looking at a 1.9 wheel rather than a 1-inch wheel, because a 1-inch wheel and a 1.9, you're looking at a huge disparity in size. Where if you're using the same size, at least, pretty close, 155. But yes, 155 would give you a little bit smaller wheel, which is probably realistic for the trailers. So yeah, what would be a good laptop for doing this CAD design? You don't need much. Fusion 360 is not super demanding, luckily. You don't need much. Just you should be able to load it onto nearly anything. I know a lot of people in here had said that they were using, you know, 5-8-year-old laptops, and it wasn't too much problem. The 1.9 Vitera Suburban wheels, yeah, they're kind of like a steely style, but we're gonna design it around some reasonably sized tires. Maybe we make it so that the fenders are adjustable in case someone doesn't have smaller tires, they want to use larger, or maybe they have really small tires, but they don't want this huge fender gap. We'll make the fenders adjustable. Just little things like that we can think through, and that way you guys end up with a trailer in the end that looks reasonable. I'm not going to probably tow a trailer. Maybe I'll build one just because, but if we think it through, I think we can make it so that any of you guys are going to be able to end up with something that you like in the end. And I'm gonna rename this series. It's gonna be 3D Printing Sunday rather than STL Sunday. That way I think we'll get more and more people in here. If we get more people, this will, become a little bit more popular, and we'll end up with decent support out of the live. You guys have been great. We had like 160 some people tonight. That was fantastic. So for this series, not as popular as like building a kit on Friday nights, but still awesome. Since I ordered an ender, thanks to you, my wife says, thanks, by the way. What software do you use to put the files into the actual printer? So I'll switch back here. So let's go back to our washing machine. I'll just show, let's run through this. We've ran through this before, but I think it's always a good exercise. So we need to break this apart, really. You want to print each of these files individually. Now, if you're on Fusion here, this top body here, I'm going to go in the tree on the left. We expanded it, and you can see the body list here. If you go there and you right click on the body and then you go save as STL, this little screen will pop up. We're going to do save as washing machine top, save. We're going to do that for all of them. I have to do this anyway to upload these files. So we're going right click, washing machine body. I don't know. This is washing machine drive pulley. I might as washing machine drum. And lastly, we have the lid. So then for me, I use Cura. Ultimaker Cura, it's free. There's a lot of options for other ones that you can use. Let's see, but there's a ton of different softwares. I'm not sure which, most of them will work with most printers. There's going to be different settings in there, but this one is pretty widely used, and it's already going to be set up for support of the enders especially. So you're going to be able to click and create the stuff. Oh, there it goes. Sorry, took forever. So this is how it opens up, and this is basically the volume of your machine. So you can see up here on the left side it says TiVo Tornado. That's mine. If you had your printer, like you just got it and that wasn't there, you'd hit Add Printer. You would go to, let's see. Well, it's Creality, isn't it? So Creality, and then see there's a huge list of Crealities here. Here's your Ender 3, Ender 3 Pro. You'd select which one, and then you'd be ready to go. So once you're in here, though, you go to File, Open Files, and now let's go to 3D Printing Files, and let's just select all of the ones from the washing. So here's all of those files. So based on how we drew these things, I'm probably going to print this exactly like you see it. That. Actually, I think I would print all of these exactly like they came in. But you can also do per model settings. So, like for example, see over here it says per model settings. So some of them we may want, support on, and some of you. So let's do select set to generate support. So like this one here, I want to generate support, but I also, let's see, will it allow me? There's a few things you can do. Oops. What I want mainly is I want this to only generate support on the build plate only. So in this big list here, where support is, I want generate support, touching build plate only. That's exactly what I want. So if I slice this whole thing as it's shown, we're going to do that. And then I'm going to hit preview up at the top. And it's going to show me, so see here, this down here is support material around the bottom because it wouldn't be able to print that easily for what it had. So that's fine. And see, there's no support on the inside, which is exactly what I wanted. I only wanted the support on the bottom. This one here, a little bit of support around the outside, which is fine. And I don't... This one here, we may run into some issues with needing support. Or what I might do before I finish this is I might go... Actually, that's exactly what I'm going to do. I'm going to go put some big chamfers underneath of these pedestals so that it will slowly support itself rather than needing to print it with support. So, oh, I see my 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 face is in the way. But so I'm going to go make a couple of modifications to the file just to make sure things print even easier. But this is not super important to be doing on here. But what I'll show you what I'm going to do. So I'm going to add this, and that way it can slowly build out to it rather than actually having to use support material. See? And so, anyway, we'll call this thing a night. Appreciate all you guys for watching. What support angle do you typically use? Oh, man. I have to go back and check. I guess since I'm in Cura, I can just go check what my support angle settings are at. I have mine set at 50 right now, which is usually adequate. That bottom bridge might need some too. What bottom bridge were you talking about? These will both need it for sure, but I was just gonna... That shouldn't need it. I think this will be fine. That will need it there. I don't know where else it would need it. 50 is default on Cura. Yeah, that sounds right. My CR10S will do 65 easily. Yeah, you know, honestly, so much of this stuff, usually I design with thinking about it in advance, and I only, if it's a part that I know is going to need it, I'll turn it on, and then normally it puts it where I want. That's about it. Beyond that, I don't normally use a lot of support just because I kind of design with the thought that I don't want it. Hey, thanks for the $10, Ben. Appreciate it. So hopefully that gives you guys some idea. I feel like I should print this thing. 14 hours of printing. Worth it, though. What do I have my settings at? 2 point at draft. Yeah. There's some big features. But we all need 3. Oh, I don't have any white PLA. I'm going to have to get some white PLA first. I don't want a black washing machine. It's got to be white. But anyway, thanks for watching, everybody. Appreciate it. Good times. We'll see you guys next Sunday for 3D Printing Sunday. I've got on Friday night, we'll be back with a kit build. I had one for this weekend, but I figured with the holiday weekend, everyone would be out. So we didn't do it. But everything else is back on schedule as normal. So we'll see you then. Wednesday, Matt and I live takeover. I don't know if we're going to do a guest this week or not, but it's going to be good. So anyway, thanks as always, guys. John sent me a message on Instagram. Thanks, John. I'll get you an Amazon gift card. So as always, thanks, guys. We'll see you next time.